Welcome back to System Prompt. Episode number 21. We're in the 1% already, so I can't keep saying that. I can't keep saying that this is amazing that we're in the 1% because we're in the 1%. We're firmly in the 1%. So Peter, you got a break for the
Yeah.
next several episodes.
Yeah.
But we're back. We're swimming in the 1%, brother. We're doing the backstroke in the
Yeah, right.
1%. And this is how
Gotta
it
keep going.
feels. Feels good, man. Welcome back to System Prompt. My name is Val,
And I'm Peter.
and this is episode number 21, and we're talking about evals. Not me, Val, evals, which is evaluations. This is the backbone to getting these AI agents and these models to do what we want it to do consistently. And long overdue, maybe, Peter. Maybe long overdue, but probably right on time. What are your thoughts?
I think this is right on time. I think, as we're pushing into, especially when we're evaluating different agents and different harnesses and seeing how they operate, we actually have to start thinking about what are going to be our evals. What are going to be our evals? Are we going to stick to the market example, the broader example that people are doing, or are we going to come up with our own evals? I mean, I think coming up with our own evals is definitely a lot better than anything, right? And then and that's what this episode is about. How do we build it? Let's have this conversation about evals. What are evals, first of all? You see all these acronyms, right? You see all these acronyms and all these pages, and you're like, oh, look, it's higher, but what the hell is MMLU? What does that mean? What is
Yeah, this is all new, man. And these, I mean, obviously, some level of evals have been around for forever in software engineering. However, we're talking about more so AI evaluations. This is relatively new because everybody kept bumping their head on the same issues and trying to figure out how to solve them. And this is really the counterpunch to, oh, AI is never going to work. For all the people who are the doom and gloomers saying AI is never going to work, there's a ton of really smart people, maybe two on this actual episode, who are working to kind of tweak it a little bit and get the AIs to AI agentic workflows and models to give out consistent outputs. But what are they? What are they? What do they mean? What is this word? What does it mean? Talk to me, Peter.
let's give it the dictionary definition to start with, right? And evals basically give the system a task, define the success of that task, and then measure what happened. Right? This is we're gonna dumb this down. We're slimming this down to what it is. But there are different levels, right? The different levels of the things that we're going to be discussing here: model capability, model behavior, full system behavior, and then actual user business outcome. Right? None of these are interchangeable. Uh, let's get started. Quick evals that you guys know, you guys have seen, you guys know what these things are. MMLU. Do you know what it is? It's really just a broad knowledge eval. Does this model, where does this model rank in this evaluation? Sometimes it's multiple choice, sometimes, etc. Then you have the GPQA or AIME, which is basically like scientist or college degree level reasoning, right? Does it match that? Does it beat that? Does it meet it? Then you have your human eval, live code bench, SWE style test. This is your software engineering tests for coding. Um, then you have your BFCL, which is your tool slash function calling. You have your IF eval, IF bench, instruction following. And then you have Ella Marina, which I know Val is very fond of. And that's where you have your human preference. But the important question isn't which benchmark is best. You have to think about which benchmark is actually applying to the thing you're trying to apply your agent towards. And one of the things that really aren't, I don't see it being discussed a lot, especially pertaining to these evals, what harness is being used for each of these evaluations? Because something needs to be putting this code together, running this code, evaluating this code. Something needs to be instructing how the model of how to tool call or how to function call or a brief summary or one shot or even a zero shot. And having these tools available for these models, but you don't see that on an eval list, right? You don't
Yeah.
see what's going on there. You don't see what harness did they use? How did they, and are they using Claude Code for, and are they using, because Claude Code, you can interchange models. Are they using Claude Code and trying to evaluate Opus versus DeepSeek? But the harness was made for Opus. Obviously, Opus is going to kill it in a in a situation.
Peter's tugging at my heartstrings right now. This is what's happening here. This, if you see why he's so excited, he's tugging at my heartstrings because this is what we talk about so much off camera, and it's true. It's so true. It's there's people banging their head against the wall because an agentic workflow that they created is failing at a certain point, and they're looking at the code and they're saying the code is good, but what they didn't realize is that the model they chose is poor at tool calling, and the point of failure is tool calling. And being able to go and say, oh, okay, I'm not crazy. The benchmark for everybody who's evaluated this model says that they're not even in the top 10. These are architectural decisions that you should be able to make when you understand these evals, to say, oh, this is where I got to swap this thing out, and then go and test again. Not just swap it out because it was 5 on the benchmark, but you're saying such an important, you got to say it again for the people in the back, because you're saying something that's so important when you're talking about building out a harness. And when we're so excited about this agent harness conversation, because we believe that a lot of the future uses of AI are going to be custom harnesses for a particular task. And that starts at being able to create custom evals and custom harnesses for that particular task. So, you gotta say it again for the people in the back, man. And it's such an important point. I have to emphasize it.
Yeah, look, again, like you're saying, when you're looking at these evals and these benchmarks, the thing that you really need to put kind of an exclamation mark on is what harness is being used, because that harness that's being used is going to determine the success and the viability of that model. Now, you can, if you can put it in one harness and and it can completely tank, and then you put it in another harness and it excels, is was that a good test? Now, if one is a harness you're not using and one is a harness you are using, then yeah, you need to make sure that the harness that you are going to be using is not only appropriate, but it fits, and the model is compatible with the harness that you're trying to run on. Now, a lot of people don't really understand, but even when you have some of these, especially local models, or open source, let's say, not local, open source models, especially when they think, right, they'll have different ways of thinking. Some will have think in front of it. Some won't have think in front of it. Some will output code in a specific format. Other ones will not output code in that specific format. So when you're building harnesses, you really have to think about the transportation method in which these models are actually outputting, right? Because your evaluation needs to take that into account, and it needs to be able to score the model appropriately on that. Because if you're not, if you're missing in the transportation area, then you're not actually grading the model appropriately nor the harness appropriately. It's just failing because your evals are not robust enough to actually capture what's going on under the hood.
I mean, it's such an important point. And the thing that jumps to my head as you're saying that is, like, imagine having a car and you live in the Northeast, and the car runs perfectly fine, but when the winter comes, you didn't change your regular tires to winter tires, and all of a sudden your car is slipping around, and you're saying, "What's going on here? The car works perfectly fine, but for some reason in the winter, I can't make a turn whenever there's a little bit of snow on the ground." It's because you didn't customize the tires for that particular environment, and it seems like such a small thing until you're looking at possibly getting into an accident. And these little tiny adjustments that Peter's talking about are the kind of adjustments that you need to think about when building out this kind of agent architecture, because it doesn't seem like it's that important until something goes wrong. And then when you fix it, you're like, oh my goodness, this is like, it's like a whole new car, you know?
Yeah, yeah, no, and also it's important. Like if you were to, if we're going to continue with that analogy, if you're going to sit there and you're going to test a different car with the same tires to confirm that it's the tires that's the problem, you have to make sure that it's the same tires, right? Because if you're comparing another car with different tires and going, well, this isn't a problem, then your comparison isn't going to, it doesn't work. And when we apply that to these models, your differences are going to be quantization. FP16, BF16 versus like Q4, Q5, Q3 in some situations, and VFP4. You need to make sure that you're using the same quantization, the same harness, and you understand the transport mechanisms, right? Otherwise, your eval is not gonna, you know, and everyone loves pushing out these evals, but I don't see enough detail in a lot of these evals to really understand exactly what's going on, right? So we've got to the point we understand harnesses matter, we understand quantization matter, we understand, you know, benchmarks kind of ish, right? Um, let's go over just a couple of different ways that I applied benchmarks. I created my own benchmarks, um, and I tested. I think it's like 23 different models. Think on, think off. Uh, so the tool loop eval portion, everything ran 3 times. Now some people are going to be like, 3 times isn't enough. 3 times is enough to kind of get a general idea. I wanted to, you know, look. I had my my infrastructure running for like 19 hours for these evals. So you know, the tool loop had 5 tasks. The T1 was a single call. What's the temperature in Boston? Called get weather, returned the temperature. The T2 dependent chain lookup order, email customer, recipient tracking carried from the first call's result. Fine. T3 convert 5 kilometers to miles. No tool applies. Measured whether the model answers directly and stands its ground. T4 is error honesty, right? So we gave it a URL that actually 404, which means it wasn't there. And we wanted to see if the model would admit failure or actually fabricate numbers, which is an important thing to actually look at, right? And then you have the last one, which is a long horizon task, T5, which was a 9-hop treasure hunt. Each call needs an unguessable code from the previous response. So it's just pure state carrying. So you have an understanding whether this can carry a state across 9 separate hops. So that was just a tool calling loop. Then you had the extraction, real grammar constrained pipeline, you know, no repair round trip needed as a check, right? So your extraction needs to be perfect one time, fine. Then we had a chat discipline. We had a stop rule. We don't want a brief acknowledgement. We don't want anything, you know, would you like anything else at the end? No, we don't want any of that. We wanted exactly 3 bullet formats, bare JSON, without any sort of grammar enforcement. See what it those and that highlights instruction following, right? Can this model follow these instructions? Then we had 3 different coding tests that people would actually apply to real life. Not leak code, right? Because nobody's doing leak code. It doesn't need to be leak code, no, right? We had a messy expense CSV, quoted amounts, accounting negatives, and case normalization, right? We had a fix an off by one booking conflict bug from a bug report that we saw, right? Uh, and then we built a log summarizer to an exact output specification. It was graded by running the code against basic edge assertions. And that's it. That was the entire eval. That was the eval we ran, right? We're not going to sit there and measure its specific intelligence because we needed to make sure it can do the job. We and I think the what we saw was actually kind of frightening in terms of what it could actually do. But we got some models that were actually perfect in it, 3 to be exact. And I think you'd be surprised at actually which ones, comparative to some of the ones that are rolling out now. But those are the evals. Why did we set up those evals the way that we did? It's because these are things that we ask the model to do all the time. We ask it to do extraction all the time. It needs to be exacting when it extracts. We ask it to generate code to fix things, right? Not big huge programs, but analyze this CSV, right? Or this Excel sheet.
Yeah.
These are things we ask it all the time. What is going on with this booking application? Find the bug. All the time, if you're using AI, you're asking it to do things. A log summarizer. Look at this log and summarize it for me. These are things you're going to be using it for. Guaranteed, right? Tool calling is important. Now, I don't want to. I'm not gonna. I don't want to display the results here, but I want to kind of kick it over to you, Val. Do you have any questions on this? What do you think about this way to run evaluations on AI models?
Well, I think as a base level for just kind of seeing what you have, I thought it was great. I think that was the 9 step hop. I thought was great. Um, and then understanding, um, giving it easy stuff that you're supposed to get the output all the time is a very common one because sometimes we're asking questions. Bro, I had this issue. I don't want to call out the company, but let's say I had an issue with the company recently where and this is a large company, and I was talking to their chatbot, their AI powered chatbot, and it fabricated an account number related to my account. I said, what the heck? But our conversation's been going on for a while. So I knew that unless they had a pretty good harness, watch out. So that's why I don't want to call them out because, I don't want to call them out. But
That's libel.
yeah, I don't.
Unless we can reproduce it on air.
I took screenshots, brother.
Wait,
I took screenshots, but I don't want to call them out. I don't want to call them out. Hey, man, the, the rep acknowledged that AI can give errors and so on and so forth. But the point I'm trying to say is that there should be certain things that the output should almost be one to one all the time. And how do you make sure to keep the models honest running these type of evaluations? Because there are some models that do that well. Now, would that be the same exact model that will give you a physics paper or write you a beautiful poem or generate you an image or a video? No, probably not. But this is where determining which model you should use for which task optimizes the harness. And if we go back to the car example, it's like putting the wrong fuel in the car and not getting the same output. Yeah, you're getting something, but the car was not made for. It's been a while since I've driven, so I feel like I'm gonna throw the numbers off. But it's not made for 93, or it's not made for 87. It's made for 93, and you put 87 in there. Am I right? I feel like I'm in New York, guys.
a
But
little high.
but the
Yeah.
but yeah. So I thought it's a very base level evaluation, especially if you're for what we're talking about when we're trying to evaluate how these models work on a local device. When we're trying to figure out what kind of routing we want to use for which model, getting a heat check is great, man. Especially when there's so many models coming out now. And if you have a local device and you could just run these models through these kind of basic gymnastics, yeah, you could use the common benchmarks that we see online, but kind of having your own, I think is not only is it good to have, I honestly believe it's going to be the norm in the next few years when people are trying to figure out which model to switch to. They're going to have their own internal evals that are not specific to an agentic feature that they're running for the finance department or HR, but just to kind of determine which model are we going to bring in house as we upgrade that fits our company infrastructure. And they're going to have their own kind of base level evaluation, and they're going to weed those models out. And then there's going to be maybe 7 models or so. Okay, out of these 7 models, which are the ones that fit our agentic tasks the best? And there's going to be an AI engineering department that's their only job. It's just getting new models, running these basic evals, and then disseminating the models to these other agentic workflows, and then running a second layer eval. Um, but yeah, I thought it was. Now I'm curious as to how this thing performed.
Well, we're gonna show. I'll show you a little bit about. I'll show you a little bit about how it performed a little later. But the one thing that I also want to highlight, especially, you know, a model scoring 95% once is different from one that's reliably scoring 95% across the board. Which is why you need to make sure to do. It has to be repeated. If you're going to eval a task, you do it at minimum like 3 to 5 times. You can do it a lot more. A lot more. Going to throw out my entire little scientific experiment because of 3 times per task. That's not good enough. You know what? And to some degree, they're right. But again, like you highlighted, this is a heat check to see if these models can actually do it. And if they could do it 3 times in a row and they can nail it, then you pick the ones that are nailing it consecutively, and then you can pick those models at being able to being a much longer, wider eval without having to touch all these models. Because
Yeah.
if they score low with the first three tries, and you're averaging those scores, and not low, right? Because I think the lowest score that I got an overall score was actually a 43%. So I guess low enough. Um, some of these were older models, some of these were newer models, but right. Uh, but you need to make sure that when you're building this eval, it does need to be sort of in the direction of what it is you're going to be actually doing with it, so you have an understanding of how it's going to score based on the task that you're giving it. So with that being said, I will now share this window with.
We gotta get a sound effects machine because I could have did the drum roll.
Yeah, right.
Episode 40, 50. We'll get a sound effects machine maybe.
We just I mean, we could do. We'll talk about it. Okay, so the top three models: uh, GPT OSS 120 billion parameter model. At the task that I threw it, it was thinking had to be low, 100% across the board. CTOC is how many tokens it took to actually complete the task, right? And that tokens per second. It's running on a DGX Spark using Olama, so we're gonna get lower on models that are not MOE models, but that are dense models. If we change the runtime to something else, something like llama.cpp or sglang or vllm, we can squeeze and neck out a little bit more tokens a second with it. But the one thing that I want to highlight is we have a 120 billion parameter model that scored basically the highest, right? Highest tokens per second, lowest amount of token usage, 100% across the board. And then you had a 27 billion parameter model that was right behind it. That's the Quen
Yeah.
3.6, right? Quen 3.6 think off, 100% across the board. And really the Quen 3.6 model only is second because of the amount of tokens it took to complete the task. And when you're looking at that, the difference is 8 tokens. Just to give you a roundabout idea. The third one with a completed task were Gemma 4 31 billion with Think On. Now
I'm a little surprised about that. If I'm being, I would. This is why I wouldn't have guessed. I'm a little surprised about that.
well, they've been working on the tool calling for Gemma specifically, right? So the tool calling for Gemma models has gotten better, especially as Olama. Remember, this is specifically with Olama, right? So you're talking about going through Olama for the tool calling, going through Olama for all of these items. So we're really also measuring Olama along with my harness, along with the models against that are living in there. The interesting thing about it was when you look at number 4, it's GPT OSS. It's 120 billion per monitor with Think On. The tool call actually scored less than Think Off. It doesn't. Yeah. So I
Yeah.
want. Yeah, and it doubled the amount of tokens it used.
And
Um,
honestly, dude, this is what we're talking about, man. This is why it's important because how do you choose, man? There's so many options, and it's only gonna get worse. How do you? There. This is why I'm telling. And Peter and I talk about this offline. We talk about a lot of things offline, but this is why we think it's important to kind of have these heat checks because at some point in time, what you can't just pull it off the shelf and expect it to work this way because sometimes your assumptions or using these generic LLM boards could steer you wrong a little bit unless you go in there and get your hands dirty. Because I would honestly, outside of Quinn, I don't even think I would have picked GPT OSS to come in number one. If I'm being honest with you, bro,
no, and
Gamma definitely
yeah,
not.
yeah. Well, these are the three models that 100% what I asked it to do across the board. Interestingly enough, here's Muse Glimmer, brand new model, failed at some tool executions. Interesting. And with Think On, here is we got a flips, right? So that means it flip flopped its stance 3 times. And it flip flopped its stance 3 times in tool calling, which is why it only received 99%. But that's not, it looks like I'd be comfortable using this for maybe coding. I'd be comfortable using this for chat because it followed instructions, extraction, maybe tool calling, not so much. Or at least not with Think On. but think off, it actually decreased. This is the DeepSeek V4 Flash, the one that I'm using. It's actually Q3. Where did it not do great? In chat, didn't like following instructions to the time. What? Tool calling 100%, extracting 100%, code 100%. I'm a little bit forgiving here because I don't need exact. I don't need it to be exact every time. Right? Fine. You want to see another brand new model?
So, bro,
Nematron 3.5 Lightning.
this is another one I'm a little surprised about, dude. You know,
think
I'm,
off. Think off. Look where Think On scored. 18.
especially since these models came out so much further after GPT OSS 120. Like, what is it? Almost a year, maybe?
Yeah. I was surprised as hell too. But keep in mind, all of these are using like the GPT model uses MLX. I'm forgetting. Anyway, they're all Q4. They're all Q4. So this is not higher than Q4. This is what Olama provides with a download. We could have gotten higher quantizations, tested against higher quantizations. We didn't. People are going to be like, well, if you raise the quantizations, you're going to do more. We wanted to make sure that we measured against what people are actually going to be downloading and using. People aren't going to be sitting there messing a lot with different sorts of quantizations. And I think it gives it even more, it's more impressive, not less so, that a 27 billion parameter 100% across the board in Q4.
Yeah. And these are other evals that we can run. This is our first run, guys. So but there's gonna be more that we're gonna run, and these are the kind of comparisons that we can make to kind of give a really good picture. But for a first good once over, this is a huge filtering system based on where you are starting and where you want to be in terms of picking a model for a particular task when you're building out a harness.
Yeah, this is just some more information. I did a look, and before anybody was like, "Well, did you synthesize that yourself?" No, I didn't synthesize that myself. I decided what the evals were. I decided a lot of the things there, and I also made sure that I did have AI then synthesize the data that was returned, because otherwise this would have taken me a lot longer. One of the funny things, a lot of people are like, "Well, it's obviously model parameters." Well, DeepSeek scored 6. This is a 284 billion parameter model. You have Llama 4 Scout no think. It has no think at all. Scored 28th. This is 110 billion, 100 billion parameter model, somewhere around there. Nematron 3 Super Think Off, 29th. A lot of these surprised the hell out of me, man. And I
Yeah,
was.
bro. I'm looking through the list and I'm like, thank goodness I didn't put money on this. You know? Yeah. This is I'm a little surprised. I'm not gonna lie, man. Because I was, I mean, Peter knows I read these when models drop. This is the first thing I go to is try to see how they perform in certain areas, and I usually only really look at the areas that I use day to day: coding, tool calling, agentic workflow, blah blah blah. But we've been talking a lot more about this over the last couple months, and we knew this was the direction we're gonna lean into, and we're also still learning too, guys. So it's not like we've mastered it, and it's not just us. There's clearly a lot of other people who haven't who are learning this as well. Microsoft,
Yeah.
you know. So but we knew this was the direction we're going to go in, because we knew something was off, and how do we continue to refine our understanding? Well, or how do we continue to judge how these models are performing? Hey man, we got to go and do some evals, and we'll be expanding that over the next couple weeks and months. What that looks like to be able to provide more information, not just for us, but for anybody who's following, so we can kind of make sense of all this noise. Because if it's a lot to keep up with, man. You got to learn how to build a harness. You got to learn how to evaluate the models. You got to live. You got to work. You got to do other stuff. You got to enjoy yourself from time to time. You have to. It's a lot of moving parts. But I think the power of AI is being able to simplify those things so you can make the right decisions at the right time. And And I'm happy that we're doing that because I guarantee you I would have not picked those top three. I'll tell you right now, man.
You know what was funny? I think one of the funniest parts, I had Fable 5 run through the same kind of gauntlet. Um, and it 100% everything, right? Because it's Fable 5.
Okay, I'm about to say, bro, this is what's going on here.
But do you know how many tokens it used?
I feel like I used a lot, man.
431,000.
Goodness gracious, dude. I feel like I used a lot, dude. I feel like I used a lot. And it's like, but also at the same time, I guess I'm not too surprised. Because it's like, some people who are really intelligent are overthinkers. Doesn't mean that this is no knock on their intelligence, but would they be able to give you that answer that you need in 10 seconds, or do they need a little bit of time to do it? No shade or anything like that. Fable 5 is that intelligent worker that, man, before I give you this answer, I got to make sure I really think through this, which is the right thing to do theoretically. But sometimes you can't wait, man. Or if it costs so much, it's like, bro, I just need to know left or right. You know what I'm saying?
Well,
Um,
but there's also something to be said about a lot of these evals, right? Remember, there's a bunch of different categories here, right? So there was tool calling, extraction, chat, and code. Now, GPT OSS 20 billion parameters with Think On gave you 109 tokens a second on the DGX Spark, which is really good for a 20 billion parameter model, and over 100 tokens a second. And the only thing it didn't ace was code. So, would you use this for tool calling? Would you use this for extraction? Would you use this for chat? Across the board, that answer is yes. Then maybe it's something that any coding tasks maybe you want to route to Quen 3.6 27 billion parameter model, because maybe the tokens a second are a little bit slower on the DJX Spark, especially if you're using Olama, like I said. So maybe you use ChatGPT OSS 20 billion for a lot of tasks, and then for any coding, you just route it to the Quen model. And there's a lot of different ways that you can handle this, but this also highlights some of the strengths and weaknesses of some of these models. And
yeah,
one of the things I thought was really interesting was the disparity between it being able to complete the task. Because you have to understand, when you're evaluating a lot of these models and you have to think on or think off, you're setting token budgets also, and you're setting time limits. So when you're seeing the decreased evaluation on, let's say, on tool calling with think on, it doesn't necessarily mean it failed the tool call. It means that it went over budget or it went over time also. So that's
yeah,
also a failure mode that that we had set up there. So it's also
yeah.
something to
And
take it. Yeah,
I mean, you make a great point. I think Nvidia just dropped a model where they're saying this thing is like 6,000 tokens a second or something, or they're touting their speed, overthinking. And some people will say, well, why would you want that? Why would you want a model that's super fast but maybe not as accurate? Then the answer to that is depends on the task. If you're talking about a task where something like code generation where you want that thing to be as right as possible, then it's probably worth a little bit more time to get it right. But if you want something where the output needs to be right away, what are the scenarios? And this kind of really, honestly, this just goes back to what we've been talking about since the first episode. What is the task that needs to be executed? And then how do you do it? And these are all the components that go into executing that task properly so that the solution provides more value than what it costs you. And when you stay in that space, this is where you can start to really understand how to monetize AI, and not monetize in terms of flipping AI, but meaning like you're bringing agentic workflows into your organization and it's making you more money than it's costing you. And sadly, what we're really kind of talking about is engineering. We're talking about, this is, this agentic engineering, because it does take a couple more decisions. It does take a couple more. You have to think through these things a little bit. You have to understand what parameters you're working under, not only in the test environment, but in the real world environment, and what best matches your personal life and, more importantly, your business. But these are also all the ways that you can improve the model's output. So if you're saying this thing doesn't work, how far down the rabbit hole did you really go? You know, we
yeah.
and we're just scratching the surface of this, guy. So we're gonna be around this, doing this thing for many months to come, or at least 89 more episodes. So no, 79 more episodes.
and one of the things that I just want to touch on also is think about the hardware that's going to be coming out soon, right? And this is the and think about what harnesses you might be using. You might be using Hermes. You might be using Prime Agent. You might be using OpenClaw. You might be you might be using PyCode. You might be using OpenCode. You might be there's a bunch of them that are out there now. But it's important to set these evals right now. When you're thinking about the hardware that's being released, and you think about the models that are being released, and a lot of them are 30 billion and under models. We got two, a 27 billion and a 31 billion parameter that scored 100% across the board. A lot of this hardware that's going to be released are models you're going to be able to run on your work laptop. Are you going to be running an agent on your work laptop? Are we going to be outsourcing frontier thinking only when needed? Are we going to be, and this goes back to Val's point of engineering. That's routing, that's engineering, that's under the hood. Uh, these are the things that I look. We don't know which direction the future is going, but if I were to guess which way the future is going, my assessment would be that we're going to have a lot of on-prem, on hardware AI, with some outsourcing of frontier models when needed, and everything else that I've seen carries that. Because if I can get what I need out of a 27 billion parameter model versus a 120 billion parameter model, just think of the disparity there. It's Think about what you need to have a 120 billion parameter model versus 27 billion, and we're running in Q4, so it's a portion of what you need for the size of the model. Uh, but evals are important to understand that these models can actually do these tasks. Are we going to run just run the same evals on ChatGPT, run it through Fable? We'll drop a few bucks so you can actually see what that looks like through the API. We'll probably do some time lapse videos if we're doing some more open source on hardware, so we can look at the different. Or we'll shrink. We don't need to do 23 different models on think on, think off. Maybe we'll condense it a little bit so we can show some of it actually on air. Otherwise, it takes a long time. So running these evals, 33 different evals across these models, is 1,600 different scored tasks that took like 19, not 19, maybe like 12, 13 hours to actually complete. Just ran it overnight. And the best part about it was I actually found a bunch of things wrong with my system running evals, because a bunch of assumptions that I made. I was like, wait a second, all right, I need to fix this, I need to fix that. So it actually helped me robust my gateway plus the harness that I'm building, which these are just pros that come out of actually running the evaluations in the first place. So on that note, I'm excited. I want to see us do next week. We're going to be running some of our own evals with some different agents. Me and Val will be taking care of some of that in the back. So I think for the creation portion, I would love to sit here and show you exactly how it is to create, and maybe we'll do an episode on creating an agent and running it and running the evals against it. But then it's going to get very time consumptive if we're doing comparative analysis here.
Yeah.
So we might have to do some recording and then fit in some time lapse videos of like, look at what we did here, and you see me yanking my hair out and
Yeah. And the truth is, we really just scratched the surface. There's, so for any of these, for the eval hawks out there, we just scratched the surface, guys. We know that there's so much further we could go down the eval rabbit hole. We're gonna give it to everybody in chunks, and we're gonna digest this, and we're gonna really try to get a deep understanding, because we really believe that this is the future. I mean, I really see a future where there's gonna be a group of medical based harnesses that work with with LLMs that are fine tuned or refined for the medical field, like a Metatron 700 billion parameter model. But the real magic is going to be in the orchestration on how these agents work with these models to give you an output where we're not trying to shoehorn all of our common tasks into these workflows that they weren't designed for. And that's really a lot of what we're doing. So that's why we really want to take the time to kind of work through this. So yes, we know that there's a lot that we didn't cover. We're going to cover it. And we're going to go down the rabbit hole, but gradually. We got time. There's no rush. We're committed to many, many more episodes. We're in the 1% already, Peter. We're here. We're here,
It's a good feeling.
It's a good feeling, we're here. But this is what to, this is one of the areas we're going to be kind of talking about, because I think this is exciting. Obviously, I think a lot of these things are exciting, but it's informative because we want to try to break this down in a way that doesn't seem too over your head. A lot of these are just, things to look out for when you're evaluating your system. So when something goes wrong, you're saying, hey, man, there is a way to fix this thing. How do I do it? Where did this happen? How do I identify it? And what can we do to improve this, as opposed to throwing the baby out with the bathwater?
Or you could throw the baby out with the bathwater and pick a new model.
Or you can throw the baby out with the bathwater and pick a new model. Oh, to have options.
Yeah.
Oh, to have options. Yeah. Or you can do that as well,
All right, guys, I wanted to thank you so much for joining us on our eval episode. If you have any questions, comments, or complaints, please comment, like, subscribe. I have to do the due diligence at the end, right? But also, if there's anything that you want us to run evaluations on specifically, or anything that you're interested in, let us know. We can add that into our evals and we can run them against our agent systems. Aside from that, you guys have a great weekend and we'll see you next week.
Thank you so much, guys.